Alright, in this video we are going to learn about the roots of quadratic equation. These are also called as zeros of the quadratic equation. What are these zeros or roots? When we graph a quadratic curve on an xy plane, this is x-axis and that's y-axis, this one y-axis. When we graph a quadratic curve, it intersects the x-axis at certain points. A maximum number of 2 points or no points at all. The points where it intersects this x-axis is known as a zero or a root. A quadratic equation can have two roots, one root which just intersects the x-axis. It just touches it and goes up, or no root at all. It lies all above the x-axis. The graph can be U-shaped or the smiley face, or this way as well. This can be one root, this has two roots, this has one root, and this has no roots at all. So it can be either way. There's a separate video about how to graph the quadratic equations. You can check its link in the description below. Okay, so let's move on. How do we know that how many roots a quadratic equation has? We don't always have to graph it. We don't need to graph a quadratic equation all the time to know it has how many roots does it have or how does it look like. We can just manipulate its equation and find it out. Okay, so to know how many roots a quadratic equation has, we need to know about the discriminant. What is the discriminant? Discriminant is actually just this formula, b squared minus 4ac, this magical formula. Whenever this b squared minus 4ac is greater than 0, whenever it's greater than 0, our quadratic equation will have will have two distinct real roots. Two distinct real roots. Or whenever our b squared minus 4ac is equal to 0, we will have repeated roots or one root. That's not two different things, that's the same thing. Repeated roots or one root. When we'll solve the example, you will see that. Or the third case is our b squared minus 4ac is less than 0. In this case, we have no roots at all. No roots at all. No roots at all. This occurs when our graph is like this or this. It does not cross the x-axis. Okay, so what is this b squared, 4 and a and c? It's actually the part of a quadratic formula. If you remember, you can go and check its video. Its link is in the description below. The formula is minus b plus minus under root b squared minus 4ac divided by 2a. Okay, you see this b squared minus 4c, this is taken from here. Whenever we solve a quadratic equation, which is like ax squared plus bx plus c equals to 0, a quadratic equation is always in this form. A can be any constant, b can be any constant, and c as well. This a should never be equal to 0 for an equation to be quadratic. For example, I'll just write an equation like 2x squared plus 5x plus 7. Like, it's a quadratic equation equals to 0. Okay, so whenever this b squared minus 4ac, this is greater than 0, we get something like minus b plus minus something, like something under root, or something positive under root, divided by 2a. And when we split it in two parts, like we take one term as a positive and one as a negative. We take minus b plus something positive divided by 2a, and minus b minus under root something positive divided by 2a. This gives us two distinct answers. So whenever this is greater than 0, we have two distinct real roots. Okay, so what happens when this is equals to 0? This equals to 0. Whenever this thing becomes 0, whenever this thing becomes 0, the whole thing, this whole under root becomes 0. And plus 0 minus 0 are the same thing. There are no two answers. We are only left with this. We are only left with this thing, minus b divided by 2a. We do not have anything else. Because under root 0 becomes 0, we are only left with minus b divided by 2a. That's our answer of if the b square minus 4ac equals to 0. This is the b we are squaring, and this is a, and that's the c. In this case, you can just see these terms accordingly, which corresponds to which. Okay, so whenever we have b square minus 4ac as a negative, which is less than 0, whenever this becomes less than 0, we get a negative term here. When we get a negative term here, it becomes a complex. It has complex roots. That's a separate topic, and there is a separate video on this. You can check it out. Its link is also in the description below. But for now, you can just know that whenever we have a negative, this under root thing negative, we have a graph which does not crosses the x-axis. It's either of these graphs, this or this. It does not crosses this x-axis. Okay, so now you know when this b square minus 4ac is greater than 0, we get two distinct real roots. Whenever it's equal to 0, we get repeated roots or one root, which I told you this. That's that one root. We get minus b divided by 2a. And whenever it's less than 0, we get no roots at all. Our graph is this type. Okay, let's solve one question and see how many roots does it have. I'll just erase it all off. You just keep in mind all these cases whenever it's greater than 0, equals 0, or less than 0. Okay, here we have three different examples, and we will find out using the discriminant how many roots does each of these have. Let's take the first one and apply our b squared minus 4ac rule. Okay, over here we have our b as minus 5 squared minus 4 times a is 1, because we have the coefficient of x squared as 1, and c is 6. Okay, so here we get minus 5 squared, we get 25, minus 4 6 are 24, minus 4 times 6 is 24, and we get our answer as 1. 1 is greater than 0, and as we just did, whenever our discriminant, our b square minus 4ac is greater than 0, we get two distinct roots. Distinct real roots are zeros. Okay, let's try it with this one, the second example. Okay, here we have our b squared as minus 6 squared, minus 4 times a is again 1, and here c is 9. Okay, let's just solve it. Minus 6 squared is positive 36, minus 4 times 9 times 4 is also 36. Okay, 36 minus 36 equals to 0. Okay, so we learned that whenever our discriminant b squared minus 4ac equals to 0, we get one or repeated roots. Repeated roots or one root. Okay, so here we just write it down. Repeated roots or one root. Okay, now let's solve the third example. Our b squared is 4 squared minus 4 times a is 1 and c is 5. Okay, so 4 squared is 25. No, 4 squared is 16, sorry, 116 minus 4 times 5 is 20. We get minus 4 as our answer, and we remember that whenever we have a minus 4 as the root, minus 4 as the discriminant, a negative number as a discriminant, it has no roots at all. Okay, so now let's check our answers. Is this all true? Let's solve this. X squared minus 5x plus 6. I see we can solve it using the factoring method, and x squared. Okay, let's use the quadratic formula. That'll save us. That'll be just more emphasizing on the discriminant b squared minus 4ac. I'll just use it. That's why whenever we have our minus 5 is minus, we have quadratic formula minus b plus minus root b squared minus 4ac divided by 2a, or minus b is minus 5, it becomes positive 5 plus minus under root b squared, that's 25, minus 4ac, we get 24 divided by 2 times 1 is 2. When we solve it further, we get 2 plus minus under root 1 divided by 2, and under root 1 is 1, under root 1 is 1, so here we get 5 plus 1 divided by 2 and 5 minus 1 divided by 2, 6. 5 plus 1 6, 6 is divided by 2, we get 3, and 5 minus 1 is 2, 5 minus 1 is 4, 4 divided by 2, we get 2 as our answer. It has two real roots, two distinct real roots. These both are different, and these are the two roots of this equation. Let's solve the second one and see if it really has one repeated root, and let's see what repeated roots are. Okay, here we have our b squared as minus 6 squared. No, minus b is a minus 6. It becomes positive 6 plus minus under root b squared is 36, because minus 6 squared is positive 36, minus 4 times x coefficient is 1, so we just won't write it, and 4 times c, it's our 9. Okay, so we get plus 6 plus minus under root 36 minus 4 times 9 is also 36 divided by 2a. A is 1, so we just won't write it. And then when we solve it, 36 minus 36 becomes 0, so this whole thing just cancels out, it becomes a 0, and here we get plus 6 divided by 2 and 3 as our answer. Okay, here we only have one answer, one root. Okay, when we solve it using the factoring method, let's use the factoring method to solve this, and I'll show you how it has repeated roots. When we do it, we have x squared minus 6x plus 9. When we take the LCM of 9, we get 3 times 3, 3 times 1. Okay, we have two numbers which when we multiply we get a 9, and when we add minus 3 with minus 3 we get a minus 6. So we have two such numbers. We get x squared minus 3x plus 9. Okay, I just did that so quickly because I already taught the factoring method in a different video. You can check its link is in the description below. Okay, so when we factor out x, we take x as common, we get x minus 3, and again we take minus 3 as common, we get x. When we take minus as common, this also becomes minus 3. Okay, so here we get x minus 3 and x minus 3. These are our two roots, x minus 3. When we we have to keep it all equal to 0. Okay, when we keep them equal to 0, we get x minus 3 equals to 0 and x minus 3 equals to 0. Okay, we get x equals to 3, x equals to 3. This shows we have repeated roots. These two things show up 2 times. X equals to 3, x equals to 3. Okay, so let's solve this third example using the quadratic formula and see if it has roots or not. Okay, here we have our minus b is minus 4 plus minus under root b squared. We have 16 minus 4. A is 1 because x's coefficient is 1 and c is 5 divided by 2. A is 1. Okay, so when we solve it, we get minus 4 plus minus under root 4 times 5 is 20. 16 minus 20, we get minus 4 divided by 2. Whenever we get this a minus sign in under this square root sign, we cannot solve it further without using the complex numbers, having complex roots. So as we cannot solve it further without having the complex roots, so we know that this equation does not have the real roots, the intersection points on the x-axis. It does not have these points. It goes all the way up or all the way down. Okay, so here we learn about the roots of quadratic equation, what these roots are, and how the discriminant works out in telling us how many roots a quadratic equation has. Okay, in the next video we will do the sum of roots and the product of roots of quadratic equation. It's an important topic and it's a short topic. We will cover it in the next video. So I'll see you next time in that video. Thanks for watching.